Good day, viewers all over the world. You are welcome to Toidel online class. Today we want to talk about linear equations. So that is when we have first order differential equations that is linear. So how do we solve linear first order differential equations? So our first order differential equation has this form. This is the form of our first order differential equation. That is when we have dy dx plus a function of x here. P of x is a function of x beside y will be equal to everything that you are going to have at the right hand side must be a function of x. So this is the general form of a first order differential equation. So how do we generate the solution to this first order differential equation? So we are going to introduce what is called an integrating factor. So an integrating factor for this equation 1, which is the general form of linear equation, is this the integrating factor. Just say it's equal to exponential integral function of x here, p of x dx. So this integrating factor actually depends on x and independent of y. So this integrating factor here is a function of x, is independent of y. Then how do we now solve? Then the equation that can be solved as we now pick y multiplied by integrating factor. The derivative of y multiplied by integrating factor will be equal to integrating factor multiplied by q of x, what we have at the right hand side. So by the time we integrate both sides with respect to x, we'll be able to solve that linear equations. So this is how to solve our linear equations. I'm going to give two examples. Let's consider two examples so that we're able to understand the whole process. So I'll start with example 1. Let's start with the first example. And what is that example? We have to solve the differential equation. Solve the differential equation. What is the equation? Y prime minus 3y is equal to 6. So it's very simple. Y prime is same thing as dy dx minus 3y is equal to 6. So if you compare this with the general form of differential equation, what can you say about this? This same thing as y prime minus p of xy is equal to q of x. This is general form of quadratic equation. Okay? This is general form of quadratic equation. So here we realize that p of x here is a constant 3. What we have beside y is p of x. That's minus 3. It's minus 3. Then q of x is also a constant. It's 6. So the first thing that we are going to do here is to find the integrating factor. So how do we find the integrating factor? We know that the integrating factor by formula is exponential integral p of x dx. That is, here we are going to have exponential integral minus 3 dx. Of course, minus 3 can come out. We have exponential minus 3 dx. So this will be same thing as the integrating factor. The integrating factor will now be equal to exponential minus 3x. That's what you are going to get. That will be the value of the integrating factor. So we have gotten the integrating factor, and that's the value of the integrating factor. So when we get the integrating factor, what is the next step to do? Then the solution. Let me clean this side. We have gotten the integrating factor. So since we have gotten the integrating factor, I can write the solution. So the solution to this problem, the solution will now be d dx integrating factor. Okay, the dx y multiplied by integrating factor will now be equal to integrating factor q of x. That will be the solution. So that will be the solution. That is what I'm trying to say, is that we say dx. What is the integrating factor? We put it inside. The integrating factor is minus 3x. That's the integrating factor. Okay, that will be exponential. That will be y exponential minus 3x to be equal to integrating factor. To be equal to what's the integrating factor here? Exponential minus 3x multiplied by what's q of x? Q of x from here is 6. So that will be 6. That will be 6. So when we find the integral of both sides, when we integrate both sides, when we introduce integral to both sides, integral will take care of dy dx. Then we are going to have y exponential minus 3x here will be equal to 6 can come outside. What is the exponential of this? When we integrate exponential minus 3x, so when we integrate this, what do we get? So when we integrate this, what do we get? So here, this will be 6. When we integrate the exponential function, just differentiate what we have there and use it to divide. This will be 6 multiplied by exponential minus 3x all over minus 3. That's what we are going to get there, plus arbitrary constant. So from here 1, here 2, we are going to have y exponential minus 3x to be equal to this. So here we are going to have y exponential minus 3x will now be equal to, this will take care of this, it will be equal to minus 2 exponential minus 3x plus arbitrary constant. That is what we are going to get. That's what we are going to get. Then we can, from here we can divide both sides by exponential minus 3x, exponential minus 3x, exponential minus 3x, so that y, this will cancel this. Y will now be equal to minus 2. This will take care of this. Minus 2 plus c exponential 3x. Finally, the solution y will be equal to minus 2 plus c exponential 3x. That will be the solution to the first order differential equation. So that will be the solution to the first order differential equation. And if you like, you can just write it and say y is equal to ce3x minus 2. Still the same thing. So let's take another example. Under first order linear differential equation. So let's take another example. That will be example 2. So under this example 2, we have to solve x plus 1 dy dx, then plus y is equal to x plus 1 all squared. This is another example. So in this case, what do we do? How do we solve this? That's what we are about to do now. How do we solve this? I want us to solve this and be a bit faster. Let me divide the board into 2. Okay, how do we solve this? We are given x plus 1 dy dx. Let me change dy dx to y prime plus y is equal to x plus 1 all squared. The first thing is that we rewrite this equation in the form of first order differential equation. Let's divide through by x plus 1. Let's divide through by x plus 1. X plus 1. This will reduce this. This will take care of this. At the end of the day, we are going to have y prime plus 1 all over x plus 1. Okay, y will be equal to x plus 1. So we have been able to rewrite this in form of a linear equation. What we have on the board is in form of a linear equation. We have been able to rewrite it in form of a linear equation. So let's look at it very well. So from here now, what you have beside y is p. So we can say p of x is equal to 1 all over x plus 1. Okay, that will be 1 all over x plus 1. That's p of x. Then q of x, what we have at the right hand side is what? X plus 1. So we go ahead and find the integrating factor. The integrating factor is exponential p of x dx. In this case, it will be exponential 1 all over x plus 1 dx. Then what would this give us? When we integrate this, when we find it, this will be exponential. When we find integral of 1 over x plus 1 dx, it's going to give us n x plus 1. Then n can take care of this. Exponential will take care of this in. At the end of the day, the final answer will be x plus 1. So the integrating factor here will be x plus 1. That will be the final answer. The integrating factor will be x plus 1. So that will be the final answer that we are going to have. So we have gotten the value of p of x and we know q of x. We've gotten the value of integrating factor. Then we know q of x to this. So what will be the solution to this differential equation? Then we know that this will be y multiplied by integrating factor will be, of course, this is what we are going to have. It will be integral q of x multiplied by integrating factor. That is, instead of writing the dx, y multiplied by integrating factor and introduce integral to both sides, let's just make use of this. It's still the same thing. Then from there, what is y? Y then multiplied by the integrating factor is x plus 1 will be equal to integral. What is q of x? It's also x plus 1. X plus 1 multiplied by integrating factor x plus 1 dx. That's what we are going to get. Then y plus x plus y multiplied by x plus 1 will now be equal to x plus 1 all squared dx, integral of x plus 1 all squared. So what do we do there? What are we going to do there? So when we integrate this, what are we going to get? This is going to give us x plus 1 cube all over 3 plus arbitrary constant. So y into brackets x plus 1 will give us that. Of course, we can divide through by x plus 1. We can try to divide through by x plus 1. So that at the end of the day, we have y to be equal to x plus 1 cube all over 3 into bracket x plus 1, then plus c all over x plus 1. So this reduces to 2. Finally, y can be equal to x plus 1 all squared all over 3 plus c all over x plus 1. This is what we're going to get as our final answer. So that's what we're going to get as our final answer. So we should take note that if we want to solve any problem under linear equations, there's need for us to rewrite the problem as the general form of linear equation. You will write the problem as the general form of linear equation, then go ahead and find the integrating factor, then locate the Q of S, then put up the solution. This is the solution. Just say y multiplied by integrating factor will be equal to integral q of x multiplied by integrating factor dx. Then you get the final answer. Thank you.